Hello students, now I am coming up with model 4 session 2. This discussion going to be very interesting, and we can see these in a real time, or in other words we can see these things in and around us. So let us start the things. So today we are speaking on embedded system application and domain specific. Okay, so when I say domain specific, what is the meaning here? They are specifically built for certain application in certain domains like consumer electronics, telecom, automotive, industrial control, etc. In general purpose computing, it is possible to replace a system with another system which is closely matching with the existing system, whereas it is not the case with embedded system. Okay, embedded systems are highly specialized in functioning and are dedicated for specific application. So let me take one application specific embedded system. So here we are considering from our discussion washing machine. I hope most of you know about this one. So let us go for this one. People experience the power of embedded system and enjoy the feature and comfort provided by them. But they are totally unaware or ignorant of the intelligent embedded player working behind the product, providing enhanced feature and comfort. Washing machine is a typical example of embedded system providing extensive support in home automation application. You can see the figure. Okay, you can see the figure, its detail again. Let us go for more brief on this one. The embedded the washing machine shown here is an Electrolux washing machine. As mentioned in previous discussion, an embedded system contains sensors, actuator, control unit and application specific user interfaces like keyboards, display units, etc. You can see all these components in a washing machine if you have a closer look at it. Some of them are visible and some of them may not be visible to you. The actuator part of washing machine consists of a motorized agitator, tumble tub, water drawing pump and inlet valve to control the flow of water into the unit. The sensor part consists of water temperature sensor, level sensor, etc. The control part contains a microprocessor or controller based board with interfaces to the sensor and actuators. The sensor data is fed back to the control unit and control unit generates the necessary actuator output. The control unit also provides connectivity to user interface like keypad for setting the washing time, selecting the type of material to be washed, light, medium, heavy duty, etc. User feedback is reflected through the display unit and LED is connected to the control board. The functional block diagram is also shown. Washing machine comes in two models, namely top loading and front loading machines. In top loading models, the agitator of the machine twists back and forth and pulls the cloth down to the bottom of the tub. On reaching the bottom of the tub, the clothes work their way back to the top of the tub where the agitator grabs them again and repeats the mechanism. In front loading machine, the clothes are tumbled and plunged into the water over and over again. Okay, so if somebody don't know how it works, for them I am giving this information. This is a first phase of washing. In second phase of washing, water is pumped out of the tub and the inner tub uses centrifugal force for wring out more water from the clothes by spinning at several hundred rotation per minute. We call it as RPM. This is called a spin phase. If you look into the keyboard panel of your washing machine, you can see three buttons, namely wash, spin and rinse. You can use these buttons to configure washing machine stages. As you can see from the picture, the inner tub of the machine contains a number of holes and during the spin cycle, the inner tube spins. The forces the water out through these holes to the stationary outer tube from which it is drained off through the outlet pipe. It is to be noted that the design of washing machine may vary from manufacturer to manufacturer, but the general principle underlying in the working of washing machine remains the same. The basic control consists of timer, cycle selector mechanism, water temperature selector, load size selector and start button. The mechanism includes motor, transmission, clutch, pump, agitator, inner tube, outer tube, and water inlet valve. Water inlet valve connects to the water supply line using at home and regulates the flow of water into the tub. Next is the integrated control panel consists of controller based board with IO interfaces and control algorithm running in it. Input interface include keyboard which consists of wash type selector namely wash, spin, rinse, cloth type selector namely light, medium, heavy duty and washing time setting, etc. The output interface consists of LED displays or LCD displays, status indication LEDs, etc. connected to the IO bus of a controller. It is to be noted that this interface may be vary from manufacturer to manufacturer and model to model. The other type of IO interfaces which are invisible to the end user are different kinds of sensor interfaces, namely water temperature sensor, water level sensor, etc. and actuator interface including motor control for agitator and tub movement control, inlet water flow control, etc. So like this application specific examples you can find many. You can go through some internet contents if you want for fridge, air conditioner, etc. Okay. So let us move to the next topic. Automotive, a domain specific example of embedded system. As we were discussing embedded system, every time I used to say one thing: any revolution, any innovation, it starts with automotive industry, because there is a scope for innovators to work in that field and there is a appreciation to their work in the automotive sector. There are other domains also such as consumer, industrial, telecom, etc. Okay, but for a time being we will consider automotive. Now this one we already discussed in our Zoom sessions, wherein I have shown how Google is working on the manless or driverless cars. Okay, how it works, how it captures the in and around environment. All the sensors are giving information to the car, where to move, how exactly the things will go for the car, okay, automatically without human intervention. Now let us look at one of the example here in detail. So inner working of automotive embedded systems. The automotive embedded systems are one where electronics takes control over mechanical system. The presence of automotive embedded system in a vehicle varies from simple mirror and wiper control to complex airbag controller and anti-lock brake system (ABS). Automotive embedded systems are normally built around microcontrollers or DSPs or hybrid of two and are generally known as electronic control units (ECUs). The number of embedded controller in an ordinary vehicle varies from 20 to 40, whereas a luxury vehicle like Mercedes-S and BMW 7 may contain 75 to 100 numbers of embedded controller. The government regulations on fuel economy, environmental factor and emission standards and increasing customer demand on safety, comfort, infotainment forces the automotive manufacturer to opt for sophisticated embedded control units within the vehicle. The first embedded system used in automotive application was microprocessor based fuel injection system introduced by Volkswagen in 1600. Okay, Volkswagen 1600 in 1968. There are various types of ECUs, electronic control units, used in automotive embedded industry and can be broadly classified into two high-speed embedded control unit and low-speed embedded control units. So first one is high-speed electronic control unit. High-speed electronic control units are deployed in critical control unit requiring fast response. They include fuel injection system, anti-brake system, anti-lock brake system, engine control, electronic throttle, steering control, transmission control unit and central control unit. Low-speed electronic control units are deployed in application where response time is not so critical. They are generally built around low-cost microcontroller and digital signal processor. Audio controller, passenger and driver door locks, door glass control, wiper control, mirror control, seat control system, headlamp and tail lamp control, sunroof control unit, etc. are examples of low-speed electronic control units. Next important point in automotive domain is automotive communication buses. Automotive application make use of serial bus for communication, which greatly reduces amount of wiring required inside a vehicle. The following discussion, what we are doing now, it will give an overview about these things. So first one is controller area network, that is called CAN. The CAN bus was originally proposed by Robert Bosch, pioneer in automotive embedded solution provider. It supports medium speed, class B and high speed data transfer. CAN is an event-driven protocol interface with support for error handling in data transmission. It is generally deployed in safety systems like airbag control, powertrain system like engine control and anti-brake system ABS, and navigation system like GPS. The protocol format and interface application development for CAN bus will be discussed, okay, if you are choosing the subject called networks, okay, but here the scope of this syllabus is not that much. So if you're interested, you can go and read about CAN, which is used in automotive communication. Next is local interconnect network, LIN. LIN bus is a single master multiple slave communication interface. LIN is low speed single wire communication interface with support for data rates up to 20 kbps and is used for sensor interfacing. LIN bus follows the master communication triggering technique to eliminate the possible bus arbitration problem that can occur by simultaneous talking of different slave nodes connected to a single interface bus. LIN bus is employed in applications like mirror control, fan control, seat positioning control, window control and position control where response time is not that critical. Next is media oriented system transport bus. In short, it is called MOST bus. The media oriented system transport is targeted for automotive audio video equipment interfacing, used primarily in European cars. The MOST bus is a multimedia fiber optic point-to-point network implemented in a star, ring or daisy chain topology over optical fiber cable. The MOST bus specification defines the physical layer as well as the application layer, network layer and media access control. MOST bus is an optical fiber cable connected between electrical optical converter EOC and optical electrical converter OEC, which would translate into optical cable MOST bus. Next important point for automotive domain is key players of the automotive embedded market. The key players of automotive embedded market can be visualized in three vertically, namely, first one is silicon provider. Silicon provider are responsible for providing the necessary chips which are used in the control application development. The chip may be a standard product like microcontroller or DSP or ADC DAC chips. Some applications may require specific chips and they are manufactured as application specific integrated chip ASIC. The leading silicon providers in the automotive industry, okay, I am giving some of the name here. Analog Devices, which a provider of world-class digital signal processing chips, precision analog microcontroller, programmable inclinometer, accelerometer, LED drivers, etc. For automotive signal processing applications, driver assistance system, audio system, GPS or navigation system, etc. Next is Xilinx. I think most of us understand this one. What is Xilinx? We have already used this software. Okay, they are also supplier of this kind of kits. Now these suppliers provide us high performance FPGAs, CPLDs and automotive specific IP cores for GPS navigation system, driver information system, distance control, collision avoidance, rear seat entertainment, adaptive cruise control, voice recognition, etc. Next is ATMEL, supplier of cost effective high density flash controllers and memories. ATMEL provides a series of high performance microcontroller, namely ARM. In our lab also we are using this one, AVR and 80C51. A wide range of application-specific standard products, ASSPs, for chassis, body, electronics, security, safety, and car infotainment, and automotive networking products for CAN, LIN, and FlexiRay are also supplied by Atmel. Next is Maxim, supplier of world-class analog digital mixed signal products. Okay, includes amplifiers, comparators, regulators, RF components, etc. for all kinds of automotive solutions. Next we have Nxp Semiconductors. I hope everybody understand who is this Nxp. Nxp means they are Philips products and supplier of 16, 8 or 32-bit flash microcontrollers. So the LPC2148 what we are using in our lab is a product of Nxp. Next we have is Renesas, provider of high-speed microcontroller and large-scale integration technology for car navigation systems, accommodating 3 transfer speed, high, medium and low. Then we have Texas Instruments, supplier of microcontroller, digital signal processor and automotive communication control chips for local interconnect, LIN bus product. Next is Fujitsu, supplier of fingerprint sensors for security applications, graphic display controller for instrument application, GPS for vehicle navigation system and different types of microcontroller and automotive control system applications. Infineon, supplier of high performance microcontroller and customized application specific chips. Next is NEC, provider of high performance controllers. So like this, if I go on speaking on some more companies, the discussion never ends. So we'll stop the discussion. There are many, you can go and search if you want some more information on this one. Then let us go for discussion on tools and platform providers. Tools and platform providers are manufacturers and suppliers of various kinds of development tools and real-time embedded system operating system for developing and debugging different control unit related application. Tools falls into 2 categories, namely embedded software application development tool and embedded hardware development tools. Sometimes the silicon supplier provides the development suite for application development using their chip. Some third-party supplier may also provide developing kits and libraries. Some of these leading suppliers of tools and end platforms automotive embedded systems are discussed now. The first one is ENEA, is an embedded technology developer of OSC real-time operating system. The OSC RTOS supports both CPU and DSP and has also been specifically developed to support multi-core and fault-tolerant system development. Next is, this is very interesting, the MathWorks. Okay, if you heard the software called MATLAB, okay, it is also developed by this team, that is MathWorks. It is the world's leading developer and supplier of technical software. It offers wide range of tools, consultancy and training for numeric computation, visualization, modeling, simulation across many different industries. MathWorks breakthrough product is MATLAB, as I told earlier, a high-level programming language and environment for technical computation, numerical analysis. Now, if I just speak in one line, from MATLAB you can design from small switch to aeroplane, a small insect to satellites. The unimaginable things you can design from the MATLAB. Next is Keel software, which we are using. The integrated development environment, that is IDE Keel Microvision for Keel software, is powerful embedded software design tool for 8051 and C116 family. Even we are using for LPC family or Nxp family, I can say, the product of Philips. Even Philips provide its own utility, but we are using Keel as it is mentioned in the syllabus. Next tool is Lotter-Batch. It is a world _1 supplier of debug tool, providing support for processor from multiple silicon vendor in automotive market. Then we have RTCN is a leading supplier of collaborative modeling tools for requirement analysis, specification, design and development of complex application. We have Microsoft. It is platform provider for automotive embedded applications. Microsoft Windows CE is powerful RTOS platform for automotive applications. Automotive features are included in the new Win CE version for providing support for automotive application developer. Last point in this is solution providers. Solution providers supply OEM and complete solution for automotive application, making use of the chip, platforms and different development tools. The major player of this domain are Bosch Automotive. Bosch, Robert Bosch, I think you have heard about this company. Bosch is providing complete automotive solution ranging from body electronics, diesel engine control, gasoline engine control, powertrain system, safety systems, in-car navigation system and infotainment system. Then we have Denso Automotive. Denso is an original equipment manufacturer, OEM, and solution provider for engine management, climate control, body electronic, driving control and safety, hybrid vehicles, embedded infotainment and communications. Then we have our own Karnataka's Infosys Technologies. Infosys is a solution provider for automotive embedded hardware and software. Infosys provides competitive edge in integrating technology change through cost-effective solution. One more very interesting company called Delphi is a complete solution provider for engine control, safety, infotainment, etc. and OEM for spark plugs, bearing, etc. and many more are there. This is a very long list again if you go and read about them. Okay, so the scope of this book doesn't allow us to discuss all things, but some few for our discussion. Okay, so hope you write the session summary and upload. Thank you.